Hello guys. My name is Christopher Pdr,
I'm Kalen Pexton.
I'm Chris Heim.
and we are presenting our medical device Inogen Rove 6, and this is our PDR section. Next slides, please. So executive summary. So essentially here we are saying our purpose, in which our purpose of this project is to design, develop, and prepare for the commercialization of the Inogen Rove 6 next generation, a portable oxygen concentrator that improves patient mobility, comfort, and independence. The design concept integrates advanced engineering in mechanical, electrical, and software systems to ensure efficient oxygen delivery in both pulse and continuous modes. In this project, we will go over the project schedule, the budgeting, the risk assessment, and the WPS. Next slide, please.
So before the project kicks off, there's a need to deliver the project charter and the preliminary design review. Upon clearance of the PDR, the project will move from phase one of project management into phase two, product design and engineering. In phase two, we will need to determine device requirements and specifications, mechanical and electrical design, software design, and eventual prototyping. Moving into phase three, we will begin to use prototype to solidify our regulatory strategy, identify risk and controls, perform verification and validation, and then submit to FDA for market clearance. Phase four will mostly comprise of design transfer, where schematics and other documents will be translated for manufacturability. Here, process lines will be set up, vendors will be finalized, and inventory will be accumulated, and the logistics and distribution networks will be planned. Phase five will be mostly marketing of the product to ensure visibility on the market and build the brand. Phase six will mostly involve customer support and maintenance, including customer support lines of communication, returns on shipping, warranty and repairs, and continuous improvement. Phase seven will include documentation of project insights as well as closure. The project follows a clear sequence of milestones with tightly linked dependencies along a critical path. It begins with project management and planning in fall 2025, where the kickoff and preliminary design review establish scope, requirements, and structure. These feed directly into design and engineering work through mid-2026, including CAD, electronic software, and the first prototype builds. Compliance and quality activities, particularly verification and validation, run through the rest of 2026 and form the longest and most resource-intensive stage. The outcomes of this phase enable regulatory submissions at the last quarter of 2026. Final marketing, branding, and sales preparations then align with regulatory clearance, leading into the global launch in November 2026. Here is a closer look at our Gantt chart. The project's critical path progresses from project management through product design and engineering, followed by verification and validation and regulatory submission, then moves into design transfer, logistics, and distribution, and ultimately concludes with the product launch to market and continuous improvement. The basis of estimates for the Inogen Rove 6 project budget was developed using a combination of vendor quotes, historical data, and project-specific assumptions. Labor costs were primarily estimated using standardized hourly rates based on past project experience with comparable medical device development efforts, while adjustments were made for specialized engineering roles such as mechanical, electrical, and software design. Material estimates were informed by supplier quotes for critical components, as well as historical bills of materials from prior oxygen concentrator programs. Fixed costs such as regulatory submissions, quality management, and clinical validation were derived from previous medical device projects with similar FDA 510(k) and CE mark pathways. Where direct quotes or historical data were not available, assumptions were made using industry benchmarks, standard costing models, and expert judgment from project stakeholders. These combined approaches provided a structured and evidence-based foundation for establishing the budget of $1,383,346 with built-in contingencies for design iteration, regulatory compliance, and manufacturing scale-up.
So as to our team's strategy for managing risk, we have a two-tier strategy. Essentially, first we have mitigation, which are actions that are trying to reduce the likelihood and impacts of risk before they happen. And examples of this include design simulations, supplier planning, and early regulatory engagement. And then secondly, we have contingencies, which are actions that we take if a risk has already occurred. So these include backup suppliers, rapid redesigns, crisis communications, or reallocating budget. This dual approach, though, allows us that or ensures us that we're both proactive and prepared to respond to issues quickly if they arise. Next slide. So here we have our higher priority risks. One is the regulatory rejection, which obviously could greatly delay the product launch, and we plan to mitigate this through early regulatory engagement and strong documentation. If it still occurs, we'll submit additional data and adjust the launch timeline and try to be as adherent to their requirements. Another high risk is supplier delays for key parts like compressors and batteries. The team's mitigations include dual sourcing and buffer stocks, just to have extras. If suppliers fall through, we'll switch to alternate vendors or prioritize limited inventory for more critical markets. And then finally, our customer support could also be overwhelmed at launch. We are considering this, and to reduce this risk, we're planning to ramp up staff and ensure just a scalable system. And then if needed, we'll also outsource overflow calls and extend support hours to third third parties. Next slide, please. And then this slide, on the other hand, highlights our less important risks. They're still very important to consider, but these are our moderate risks. One is software bugs that slip through testing, which we'll address through regular updates and validations. It's a very common flaw in software devices. Another is biocompatibility issues with the material. To mitigate this, we're going to be pre-screening and testing alternatives in parallel. And if the materials altogether fail, we can substitute them with other pre-qualified options and just pause production until we've confirmed the biocompatibility. And then finally, documentation gaps could cause some compliance issues along the way with the government, as well as handing over the project down the line. So we are obviously trying to make sure that we are at the peak in documentation as well as just overall compliance. Next slide.
As in for our disruption response, we drew two cards. The first card would be a red three hearts, which essentially is budget overrun during prototyping. And our second card we drew was the Black King, which was a neutral card, and more specifically, it was leadership notices professionalism. So in order to respond to these calls, especially the red three, we relocated funds from later phases, more specifically marketing and training. We strengthened budget monitoring and added prototyping contingency buffers, reflected changes in WBS, budget table, and risk register. And as in for our blocking, we just maintain disciplines and consistency. Next slide, please. So in conclusion, the Inogen Rope 6 positioned as a safe, effective, and competitive PLC. For our next steps, we are strengthening Inogen's market leadership and respiratory care, and we are continuing on our final deliverables. More specifically, we refined prototypes, regulatory fillings, validated manufacturing line, and we are on our path towards a successful 2027 launch. Next slide, please. And thank you, guys.